So we're going to talk about some properties of our exponents. So basically, the first thing is you need to know the big number is your base and the small number is your exponent or power, whatever you want to call it. Now, what we are applying goes to numbers or variables. So let's talk about our properties. The product of a power. That means when you multiply and it's the same base, you can add your exponents. So when I'm multiplying both of these fours, my exponents, I'm going to add them together. So 2 plus 3 gives us 5. So 4 to the fifth. Again, I'm going to add 4 plus negative 2 because I have the same base. That gives us 2. So it's x to the second power. Power of a power means I am bringing my exponent and raising it to the third power in this case. So I'm raising an exponent to a power. So all that tells us is we're going to keep our base and multiply our exponents. So 2 times 3 gives us 6. Keep your base of 3. Same thing can be done for our variable. So again, when you're keeping your base, you're multiplying both of your powers. So this one tells me I'm going to multiply 4 times 5. So x is my base. My exponent's 4 times 5, which gives me 20. So x to the 20th power. So for the power of a product, all I'm doing is taking my exponent number and multiplying my exponents with it for each exponent that's inside of my parentheses. So let's look at the first one. I'm taking this 4 and distributing it to the 1 and to the 3. Remember that if it's not written, it's assumed it's a 1. So again, there's no 1 written there. We're assuming that this one is there. So when you multiply, you're going to go 4 times 1 because that's my exponent, 2 to the 4th. 4 times my 3, which gives me 12. So it's x to the 12th. So it's 2 to the 4th, x to the 12th. Again, I'm taking this exponent and multiplying with all the exponents that are inside of my parentheses. So 2 times 3 gives me 6. 5 times 3 gives me 15. So it's x to the 6th, y to the 15th. So now let's talk about negative exponents. That just tells us wherever we have a negative exponent, it needs to move to become positive. So in this case here, it moved to my denominator because this is in the numerator. Because remember, anything can be put into a fraction by putting it over 1, whether it's a number or a variable. So in this case, it's 4 to the negative 2. That's like saying 4 over 1. It's negative where it's at, so it needs to move to my denominator in order to become positive. And 4 squared is just 16, so it's 1 over 16. X to the negative 5. Again, if you want to put it over 1 so that you know it's in the numerator and it needs to move to the denominator, go ahead. But this here needs to move to the denominator. So I'm going to have 1 over x to the 5th. Now for the last one, it's in the denominator and it's negative. So that means it needs to move to the numerator in order to become positive. So it becomes x to the 3rd power. And that is my final answer. So my 0 exponent just tells me anything to the 0 power means 1, whether it's a number or a variable. So anything to the 0 power is just 1. So 3 to the 0 power is 1. Now, when we're doing problems like that there's more than one item inside of my parentheses, you're going to take that exponent number and distribute it to every exponent number inside the parentheses. So what this really means is 5 times 0, which is 0, 2 times 0, which is 0, and negative 2 times 0 is 0. So x to the 0, y to the 0, z to the 0. That just means 1 times 1 times 1, which is just 1. So now the quotient of powers, that just tells us if they are the same base, we're going to keep our base and subtract our exponents. So in this case, 4 minus 2, because it's the same base. These are the same base. So you're going to keep your base and go 4 minus 2, which gives us 3 squared. 3 squared is 9. You need to know the simple ones like squared or cubed. Again, we're subtracting. 5 minus 3 gives us 2. You're going to keep your base of x because these are both the same. In order for you to subtract the exponents, the base has to be the same. So you're going to get 5 minus 3, which gives us 2. Now, in both of these cases, our exponent numbers in our numerator were bigger than the exponent numbers in our denominator. So that's why our answer stood in our numerator. In this last case, if you notice, the 7 in my denominator is bigger than the 2 in my numerator. So you're still going to subtract 7 minus 2 and get 5. But in order to be positive, it has to stay in my denominator. So basically, where your big number of your exponent is at, so where your big exponent number is at, that's where your answer has to stay in order to be positive. So you could go 2 minus 7, which gives us -5, and you know it needs to move to the denominator in order to be positive. Or you can just say 7 minus 2 is 5. 7's in the denominator. That's where my answer has to go to stay positive. So it's 1 over x to the 5th as my final answer. So now the last one, power of a quotient. That just tells me I'm going to take this exponent number and distribute it to everything in my denominator, in the numerator and denominator. Again, I'm going to take this exponent number and distribute it to my numerator and my denominator, and I'm distributing it to the exponents that are there. If it's not written, it's assumed it's 1. So in this case, it's going to be 3 times 1, which gives us 3. Again, 3 times 1, which gives us 3. And it's 2 to the third power, which gives us 8, and 3 to the third power, which gives us 27. So it's 8 over 27. And yes, you should know things to the third power. It's not that hard. So now in this case, you're going to take this 2 and distribute it to everything that's inside of my exponent, inside my parentheses, and it doesn't matter. Yes, you're distributing it to the exponents, but to the numerator and the denominator. So it's everything in the numerator or denominator. That's what that means. Power of a quotient. You're distributing that exponent number to all the exponents inside the parentheses, whether they're in the numerator or denominator. Again, if there is no exponent number, we assume it's 1. So 2 times my 1, 2 times 2, 2 times my 1, and 2 times my 4. So 2 times 1 is 2, 2 times 2 is 4, 2 times 1 is 2, 4 times 2 is 8. So now I can reduce 3 squared, which gives me 9. So you're going to get x squared y to the 4th over 9z to the 8th. Again, this is the simplified answer down here. That is the final answer, how it should look. The top one is correct, but it's not simplified. That would be the bottom one. So if you have any questions, please let me know. There are also another set of notes that kind of goes in more detail as to what needs to be done and a couple of examples. If you have any questions, let me know.